What is up, Unity community? Welcome back to another official Unity live stream here on twitch.tv/Unity and, of course, the official Unity YouTube page. My name is Jackson. I am one of your community managers, and it is my job to bring you all of the live stream content that you see on these channels. It is our hope that you come to these streams, that you connect with your fellow Unity community members, some of the Unity people as well, and that you step away feeling more informed, educated, capable, maybe a little inspired, all of those good things. So thank you so very much for being here with us, whether you're watching on Twitch, like we've got Liz, Ninj, Wenmen, all of the good folks over there, or if you're already here and been waiting on YouTube, like The Bull, Mark Phillips, Manish, we've got Nesna and CubeDev and Mr. Awesome and all of the good folks here early at the top of the stream. Thank you. Thank you for being here. If you are watching live, be aware that we want this to be a conversation. We want you to ask questions. We want you to provide your feedback. We want you to be here and be a part of this fantastic community. It's Shader Graph Day, you guys. It's one of the most exciting days of the month. Shader Graph Day. Some of the reasons Shader Graph Day excites me most. Number one, you guys dubbed it Shader Graph Day. You guys said, is it Shader Graph Day? And that became a thing. It stuck. We're on Shader Graph Day. Congratulations, you all. The other thing is, Ben is a wizard, I'm convinced, and always brings new and exciting things and presents them in a way that me, as a nearly no experience dev, feels like I could just take it and run. I can get it done. You know what I mean? So get excited for Shader Graph Day. If you are watching this video after the fact as a VOD on YouTube, take a look down at that navigation bar. You can skip ahead to the parts that most appeal to you. But I'm so grateful to have you all here. Unity community, please let me know. Is this anyone's first stream? Is this the first time that you've caught us live? Or if not, where in the world are you tuning in from? We've got some very, very fun things coming up. So very excited to have you all here. We do have a little bit of housekeeping before we bring in Ben and talk about all the Shader Graph things. I need to let you guys know about Unite because it's coming up and it's exciting. At Unite 2025, reconnect with the Unity community as we return to Spain for 2 full days of learning on November 19th and 20th. There'll be networking, memorable experiences, all of that good stuff. We'll be showcasing inspiring stories, demos, sessions, and an annual keynote after hours events and more. For more information, please visit unity.com/unite. Thank you to Jack working behind the scenes to add this strobe effect. That's manual, you guys. That's Jack earning his paycheck back there. He's working hard. So it's looking great. Look at us. We have a party here. Go to Unite. I was there last year. It was very, very fun. We got a couple of first timers here. Gecko Gangster. We got Buzz DX. A couple of first timers. Welcome on in, everybody. We're live here on these channels, usually Tuesdays and Thursdays. If not Tuesdays or Thursdays, today is Wednesday. And I know that's confusing and conflicting to the things that I just said, but we're here a couple times a week. Keep an eye on the YouTube page for the most up-to-date schedule and what's coming next. So Abdul Rehman, also a first-timer. Welcome. So good to have you all. So I think that's enough of that. I'm grateful to be back. Thank you for being excellent to Manu, to Esteban, and Benoit last week. We are so very grateful. But without further ado, I think it's time to bring in the wizard themselves. Please put your hands together, I guess smash your keyboard or something, and say hello to Ben Cloward, the Shader Graph Wizard. How are you, Ben?
Hey, Jackson. Thanks a lot for having me on again.
Of course, Ben, you're always welcome here. I say it all the time, and I feel like I've said it to every individual and group of people that if I had 5 Bens, my job would be incredibly easy. Because Ben, you guys don't know this, Ben comes in and is like, I've got everything I want to show people and I know exactly how I want to present it. And he gives it to me in like 20 minutes. And it's like, how's that? I was like, fantastic. Let's do it. So we're ready to go, which is very, very exciting. We also have RC in the YouTube chat, who's a first timer. So welcome on in, everybody. Again, I was told this, Ben, when I joined, and you tell me if you heard the similar things or if you experienced this yourself. I was told the best thing about Unity is the community. And I think with the YouTube and Twitch communities that we've seen and grown and developed, that's definitely been the case. The number of supportive people that show up to these streams, help each other, engage positively with us on the streams themselves as well. Fantastic. Ben, what's your experience? Is that what you've been telling people also?
Absolutely. I love interacting with the community and helping out and figuring out ways we can give you guys more tools and more features. And yeah, it's great. So thank you so much for being involved.
Awesome. We've got Buzz saying, seen a lot of amazing videos of Ben on YouTube. That's right, everybody. Ben has their own YouTube channel. Today's stream is going to be long form. It's going to be slow paced. It's going to be conversational. But if you are looking for something quick and to the point and you want shader graph tutorials, go and check out Ben's channel, youtube.com/Ben Cloward. I've put the link in the chat here. Ben's putting out, what, a video a week? Is that what?
Yeah, just about every week. And right now I'm working on a series of videos that's about performance optimization. Tomorrow I'll be publishing episode 9 of that series. So yeah, definitely check it out.
Very cool. And I know that you do the tutorials both in YouTube and both in Unity and Unreal sometimes. There's optimization, there's shader graph things. So there's a wealth of knowledge for people to learn a ton of different things. Isa Al-Sabah, apologies, says, been following your custom lighting tutorials and they are ace. So you got people familiar with your work, and that's always exciting to see, Ben. But we've got some new and exciting things to show off for people today, because the last time we had you, we dove a little bit into 6.3, which was at the time in alpha, and now I believe is officially in beta, so even more accessible to people. What are we going to be talking about today that people should be excited about?
Right. So Unity 6.3 is a huge release for shader graph. Probably our biggest ever since the tool was first introduced. And the last time that I was on the stream last month on Shader Day or Shader Graph Day, I introduced a couple of the new features that are going to be available in Unity 6.3, including 8 sets of texture coordinates, the ability to nest properties and keywords inside of subgraphs. I introduced some new interpolation options from the vertex to the fragment shader. And I also showed our brand new shader graph template browser, which allows you to get started creating a new shader from a big list of available templates. So these are all features that we talked about last time on the stream. And we had so many new features to introduce in 6.3 that one stream wasn't enough to cover all of them. So you had to have me back. Here I am again. I'm sorry about that.
Anytime you want.
But today we're going to go over 2 major new features that are also coming to 6.3. We're going to talk about the ability to customize the lighting model in shader graph. And we're also going to talk about the ability to create terrain shaders in shader graph. And both of these individually by themselves would be enough to be amazing for a point release. But we have these 2 plus everything that we talked about last time. And we even have one other really big thing that we can't go into today, which is shader graph support for UI Toolkit. We won't be going into that today, but all of these things are coming in Unity 6.3. So it's going to be a great release.
Big news, big things for sure. We also have news time on YouTube saying, love your series on using Pix, Ben. There's very little on performance testing for shaders elsewhere, so thanks. Which is very exciting. I like that we're able to sometimes we're presenting things that have been tools and features for a long time that need a little bit more knowledge, or things that are kind of getting refreshes. But it's always most exciting to dive into things that are new and upcoming and getting really, really excited for those things. I think the custom lighting stuff is very cool. Ben, this is basically, and help me out here, but this is basically going to unlock people being able to do like really stylized shader, like lighting for their scenes and things, right? Which I know we've kind of talked about with some people previously actually requesting that. They were like, hey, we're going to do shader graph stuff. Can you show me how to do like a toon shade style, or like a, just different kind of style, very stylized pieces. And that's kind of what we're unlocking.
Yeah. So generally, when we think about shader graph, we think about using it as a material editor. So we're using it to edit the properties of a material, like the base color, the normals, the smoothness, and those types of things. Um, but all of the lighting is getting calculated under the hood. So in the graph, you're just controlling like the surface properties. But then, what if I want to do something different with the lighting itself? Like you were saying, if I want to change the way that the ambient occlusion behaves, or I want to edit the fog so that it works differently. So these are all things that the engine is doing under the hood. In the graph, I'm just editing the way that, the material looks. Or pushing it even a little bit further, what if I'm creating a project for an XR device or a low-end mobile phone, and the lighting that the engine is already calculating for me is too expensive for that kind of a platform? I'd like to be able to use I'd like to be able to use simplified lighting to reduce the overall rendering cost. So actually, can we switch over to show my screen here, and I'll kind of
Can.
give you an example of kind of what I'm talking about here. So this is the Japanese garden scene that comes with Unity URP. You can create a new project with this template. And what I've got here is a version of the scene where I've changed it to use custom lighting. And the other day when I was talking to you, Jackson, I was showing you how this is going to work, and you were like, "Well, we got to show the grand finale at the very beginning." So that's what we're going to do. I want to show you a couple of variations here of what's possible to do when you can customize the lighting model. So I mentioned wanting to make the lighting calculations cheaper. So if I want to do that, in the way that I have this scene currently set up, I can just take this subgraph here called light basic and wire that in. Right now, it used to be using light URP, which is imitating the way that URP lighting works. But now I've connected up light basic. So I'm just going to save this. It's going to recompile all of our shaders for us. And now instead of using the standard URP lighting, it's using the cheaper version of the lighting that I created myself here in Shader Graph. And this version of the lighting is leaving out a bunch of features. It's not doing specular, it's not doing reflections, it's not doing fog. The purpose of this is to run as fast as possible. So this particular lighting model, I don't have a frame rate counter up here, but it does run about 20% faster than using the default built-in lighting. So customizing the lighting model is a really good way of being able to leave out features if you want to make things go faster. The other thing that you might want to do with customizing the lighting is give it a stylized look. If you want to differentiate your project from other games out there, or if you want to, like you were saying, if you want to create a toon shader or some other appearance, if you want to look like your scene is painted with watercolors, for example, you need to be able to customize the lighting model. So instead of doing realistic looking rendering, you're doing something more stylized. So let's take a look at some things that we might be able to do with that. This particular lighting model here, the one I'm calling light colorize, I'm just going to connect this up and then I'll show you what this does. So light colorize makes the whole scene black and white, except for the places where there are point lights affecting the scene.
Oh, this is
And the
so cool.
point lights introduce color into the world. So for example, it's just kind of taking a minute to compile all the shaders. But what I can do here is I can grab a point light. So this little shrine lantern thing here. And if I move it out of the screen, you can see that the scene is black and white, but then as I move it in, it introduces color into the world. So this is just like one example of the kinds of things that you can do when you have control over the way the lighting works in the graph. So you can see.
This is awesome. I don't know if I know any games offhand that use this style specifically, but it's so striking and so it stands out. I want to see people make games this way.
Yeah, and that's kind of the point. Like not just this effect specifically, but when you can control the lighting model in the graph, you don't have to know how to do any coding for this. I'm just doing stuff in shader graph and able to change the way the lighting works. So I can do this, but I can also do lots of other things. So for example, if I want to make the scene look like it's rendered with colored pencils, we'll switch over to that one. It's going to take a minute to compile here. But yeah, now my scene is drawn with colored pencils. And as soon as all the shaders compile here, I can zoom in and into the tree. You can see individual pencil lines there. So I'm able to achieve like really artistic looking styles and looks. And I can do all of this using shader graph without needing to write any code. The other thing that I can do, the other effect that I have here is like a film noir look, where everything's kind of like high contrast black and white. And typically you might do this with a post-process filter, but because I'm doing this in shader graph in the materials themselves, I can do this on a per object basis. So in this case, I've made the whole scene use this material, but I could do it on just one object, or I could do it on the whole scene except for the object that I want the player to look at. So I could
Interesting.
use this idea to support gameplay, that sort of
Pull
thing.
their eyes to a specific object. Maybe you're
Yeah.
doing puzzles and you want to lead people to the next clue a little bit. Cool. Yeah.
Okay, so the next thing that I want to do, I've kind of shown you like what it looks like when you're all done, and there's a decent amount of work that goes into this. I'm not going to lie, you need to do some work. But what I want to do is just kind of show you some very basic concepts of what it means to customize the lighting model. So let me load up this other scene here. I just have kind of a simple sample object. And this object is using the URP lit shader. In fact, I've got the graph here that it's using. Let me just zoom out so I can show you this. So it just has a regular base color texture, a normal map, and a mask map assigned to it. And it's using the URP lit target. So here it's set to lit. Now, if I want to customize the lighting, the first thing that I need to do is get the existing lighting out of the way. So instead of lit, I'm going to change it to unlit. And when I save this here, actually, let me just move this window over a little bit so that I have some more space for my graph. Yeah. Okay, so now my lighting is gone and my object looks like it's self-illuminated. So at this point, I can start using my graph to generate lighting. And there are a couple of new features that we've added in 6.3 that enable us to create custom lighting. The first one is called Keep Lighting Variants. And for those of you that are familiar with keywords in shader graph, what this does is all of the keywords that control the lighting are kept, even though we're using the unlit target. If I check this Keep Lighting Variants box, under the hood, it's keeping around all the lighting keywords so that I can still do lighting calculations, and I don't have to manage those keywords manually. It's just going to leave them in. And then the other thing that I can do is I can turn off default decal blending and default SSAO. And the reason that I want to do that is I want to calculate those things myself in the graph instead of allowing Unity to do those things under the hood. So I'm going to turn off decals and SSAOs so that I can control those myself. So those three new settings in our unlit target allow us to use unlit as a custom lighting target. Okay, so now let's just do some very basic things first. I'm going to add in this main light node, which allows us to bring in direction, color, and shadow attenuation from our light source. And then I'm going to do a dot product between the light source, direction, and the normal. So I'm just going to bring in the normal vector. And so the normal vector is controlling the direction the surface is pointing. And so what I'm doing with this dot product node is comparing, here's my light direction, here's my surface direction. If they're parallel, then my surface is lit. But if they're perpendicular, then my surface is going to be dark.
Okay.
And so that's what this dot product node does. And if I plug this into my unlit base color now, I've got the very most basic form of lighting. And if I want to use the normal map that I was using before, this is expecting a normal in world space. And so I need to transform it. So I'm going to add a transform node here. And I need to transform my normal from tangent space to world space. And so I'll just take that normal from the normal map and plug that in instead of my normal vector node. And now what you'll see is I've got lighting, but with the surface material that I had from before.
Awesome.
So, like I said, this is like the very most basic form of lighting. There's no reflections here. There's no specular. There's no ambient light. Like around here in the back, it's like solid dark black. Like there's no bounce light happening. Well, what if I want to do all those other things? It is kind of a complicated process to build specular, to build ambient, and you can definitely do it. But the good news is you don't have to, because we have created a set of sample content that already does all of this for you. So let me show you how to do how to access that. And
Awesome.
Jackson and I kind of have a running joke on the show here that if you want to hide something from somebody, so nobody will ever find it, you put it in the
Package manager.
package manager. That's right.
The thing literally built into the engine.
Yeah.
People
So
never seen that. Didn't know that was there.
we come up here under Window, Package Management, and I know it's very small on your screen. I apologize for that. So make Window, Package Management, Package Manager. And then I'm going to select the shader graph package, and you can scroll down here. We have quite a few really cool sample sets for people to look at. But the one we're specifically taking a look at right now is called Custom Lighting. And this custom lighting package, I've already imported into my project, and it just contains a ton of stuff. It's going to allow you to create, or it's going to provide for you a huge set of subgraphs. In fact, let me just show you all of these subgraphs. So there's a couple dozen subgraphs here. We have some components like this is the one that applies the decals from the scene. We have a bunch of different ways of creating ambient light. So here are all of the subgraphs that do ambient light, including one that brings in the ambient occlusion that's been calculated from the scene. There it is right there. We also have subgraphs that do all of the lighting for like a core lighting model. So here's that basic one that I showed you a minute ago that was calculated really cheap. The colorized one. There's the light noir subgraph that I was showing a minute ago. So all of these lighting models are available, pre-packaged and ready to go.
So the lighting, the noir style lighting, wasn't something that you built in preparation for this. We just pulled it from the samples.
That's right.
That's awesome. I thought that it was like Ben toiling behind the scenes to be like, look at everything that's possible. I mean, that probably happened at some point for you to have created it to begin with, but now it's just like, hey, if you want it, you can just drag and drop. That's yours now. I think that's awesome.
Yeah, that's right. Thank you. We have a couple of different ways of calculating diffuse lighting, reflectance, a couple of different ways of calculating specular highlights, and then our full lighting models here. So all of these are available from the samples. You can download the sample and just drop them right into your project. And so that's what we're going to do. I'm just going to take a minute and we're going to build our own little custom lighting shader here. So I open up the Create Node menu, and we have this lighting category in here now. And then I can open up Components. And in my case, I need diffuse, specular, and ambient. So I'm going to come here under diffuse, and we're going to add a diffuse Lambert node. And I can just hook it up. So it's saying it wants the normal and world space, and it wants the light vector. And so now if I connect this up, it's probably going to give me like pretty much exactly the same thing that we already had. Yeah.
Awesome.
So I can get rid of that dot product because this subgraph node here is doing that for us. Let's add some specular in next.
Ben, as you are, if I can stop you for just a second to address a question, because I know we kind of talked about it as we led in here. People asking, is this for URP? Is this only HDRP? And I know we had a question before we even went live. Is this going to be for HDRP, or but did we forget about that for good? And you had a really well explained response. Can you kind of share the thoughts on HDRP versus URP?
Yep. So the two different render pipelines have different targets and use cases. So the HDRP is designed to be like as realistic as possible, and its lighting is very specifically formulated to provide, lighting that is physically accurate and beautiful, and it's not intended to be edited. Because it's just like very tightly integrated into the way that everything works. So yes, you can edit the lighting model in HDRP if you want to, but it does require getting into the engine and changing shader code. Because it's really not the intention that HDRP be used that way. It's intended to be like very realistic. URP, on the other hand, is intended to be very flexible. And so if you want to create, watercolor rendering with it, great. If you want to create toon shading rendering with it, great. HDRP is designed to be realistic. URP is designed to be flexible. And so kind of what we're doing here in URP is leaning into that flexibility and providing a bunch of tools to allow you to take that flexibility and run with it and create your own style. Hope that answers the question.
Yeah, I think definitely, right? Like just different intentionalities. And if you're shooting for something that's as realistic as possible, not necessarily getting access to then stylizing it. If you're looking for something that's more customizable, then yeah, you're going to have these opportunities and options to fully stylize.
Yeah, that's right.
Cool.
Okay, so I've added this specular URP block here. And just so you can see what this is doing, I'm going to hook it up to the base color here all by itself. And now you can see that subgraph is providing that nice specular highlight for us there. And we can hook up our other values. So here's our mask texture. We can get our smoothness from that. And we can get our normal from the normal that we already calculated there. Now you can see we've got specular highlights on our cobblestones material. And now we can combine the diffuse and the specular together. So I'm just going to take my diffuse block here and I'll multiply it with the output of the specular. And then I'm going to multiply our diffuse with our diffuse texture. Kind of what I want to show here is that these building blocks that we provide are allowing you to just take the blocks and kind of connect them up together, and you can create your own lighting. So what I've done is I multiplied the diffuse texture here by the diffuse lighting. Then I multiplied the diffuse by the specular, and then I added the specular together with the diffuse. And what we're going to get at the end here is a combination of specular and diffuse.
That was quick.
Yeah.
Ben, we've got a question about diffuse Lambert. Does that equal like a matte style, like lighting? Is that the contribution it's making?
Yeah, so diffuse lighting is lighting that is diffused. That's why it's called diffuse. And so if the light source is coming in a specific direction, it hits the surface and it gets scattered.
Got it.
And so that's what we're seeing.
Okay.
Specular lighting is lighting that's focused. So light comes in, it hits the surface, it gets reflected in one specific direction or one
Okay.
specific like cone of directions. And
Got
so
it.
our surface has both specular and diffuse response.
Cool.
And so now the thing that we have left here is we need some ambient. And so I'm just going to come here to our lighting components, ambient. And like I said, all of these subgraphs are available and come with the sample that I showed you how to find from the package manager. So here's our ambient subgraph. And I can just take the base color and wire that in. I can take the normal, wire that in. I can take metallic from my masks here. I can take smoothness, ambient occlusion. And so now my ambient is ready, and all I need to do is add it onto the end of the rest of these. And right now you can see like around the dark side of the object, it's just completely black. But once I add in my ambient, you're going to see now I've got some bounce lighting there. So in just a few minutes, like I don't know, were you timing how long it took me to make that graph?
Honestly, I wish I was, because that was quick.
Yeah, so I was able to build my own custom lighting model. And if I wanted this to be cheaper, you know, I could get rid of the ambient, or I could get rid of the specular, or like I could not. If I wanted to add fog, fog would come here at the end. I could add in the, whoops. I can add in the fog block. You know, so the idea here is that we're making it really easy and modular to pull all these pieces together, so that you can build your own model and then customize it and not do things that you don't need and add in extra things or change around the way that things work. It's designed to be really flexible and modular, just to give people the ability to achieve what they need and pay for the features that they want and leave out the ones that they don't.
Awesome. Speaking of paying for things, Mr. Awesome earlier asked for these effects. I guess the ones that came from the samples, the noirs, the different lighting effects. Do they have negligible GPU costs?
The idea is to allow you to control that.
Awesome.
So what I've done here is kind of imitate like what URP is already doing. And so if I come in here and go to lighting models, and then I pick lit URP, all of this stuff that I just created manually, just to kind of show you how it works, is encapsulated inside this subgraph. And if you use the URP lit shader, for example, this is the same math that's doing. So the GPU cost that you're paying is basically like exactly the same. But then if you want to, you can tell it, hey, I don't need reflections, or I don't need fog, or I don't need screen space ambient occlusion, and you can make it cheaper. Or if you want to change it, you can do stylization. So you can do different kinds of things with it instead of just, what's available by default. So I hope that answers that. The expense of it on the GPU depends on what you choose to put in and what you choose to leave out. If you want to exactly imitate what URP is doing, you can do that, and it will cost exactly the same. So there's no difference between building URP's lighting in shader graph or allowing the engine to do it under the hood. But the main difference is it's modular now and it's in the graph, so you can change it the way that you want it to be.
Awesome.
Yeah, that's a great question.
Mm-hmm.
Okay, so let's switch back to our Japanese garden scene again. And I want to show you just a little bit under the hood so that you can understand like what's happening in this scene. Let's just switch this back to the light URP, just so that it looks normal. What I've done with this scene is most of the objects in this scene were using the standard URP lit shader. And what I did is I created a new shader that looks like this. And this imitates what URP lit is already doing. And by the way, it's really easy to create this shader that's imitating what URP lit is doing. At the risk of repeating like some of the material that I showed off last week, you can create this shader in Unity 6.3 just by choosing Create Shader Graph from Template. So here's our brand new template browser. And then you can choose a template from here. And if you choose Lit Full or Lit Basic, both of these are doing the URP lit lighting. And what I did is I just took these and converted them to the unlit shader. So you can see it's using unlit here, and it's got our 3 settings. I'm using Keep Lighting Variance. Default decal blending is off, and default SSAO is off. And then I added this new subgraph here, which is now doing my lighting. And so if we come in here, I have all of these. And when you said, I thought this was something you set up custom for the stream.
Yeah.
The custom part that I added is normally you would just have one lighting block in here, but I've added all of these others so that it was easy to just like connect them, to swap them in and out.
Right.
But what this is you know, the lighting here is basically plug and play. So this is the block that's doing the URP lighting. But if I want it to have tune lighting, I can plug in the light tune instead. So just to back up a little bit and make sure that everybody understands what I've done. I've gone through and replaced all of the shaders in my scene here with this particular graph. And so now that the materials in the scene are using this graph, it's really easy for me to then edit the graph and swap my lighting models in and out. So if I want to use tune lighting, for example, I just wire up the tune lighting model. And now my scene is rendered with tune lighting. And if I come over here, you can see that the lighting has kind of these hard edges.
Right.
Or like if I come here, like closer into this door, actually, there we go. Yeah, you can see like you get those like nice concentric outlines on things. So you get nice stylized cartoon lighting.
It's very cool.
Okay, let's see. I'm just going to take a look at my notes here and see if I missed anything.
Please. And if it's helpful, we also have a couple of questions still coming in. So
okay, yeah, let's do that.
This is a question that is outside my scope. So Ben, maybe you can help me kind of decipher it a little bit. But
Sure.
Ajaz MM says, does it work in forward only or in deferred too? Can you modify the light pass exclusively in deferred? And I know this came in earlier.
Yeah. Yeah, no, that's a great question. This is for forward and forward plus. And the reason for that is because when we're in those lighting models, we have the material surface description and the lighting all happening together in one shader. With deferred, you have the material description happening and then rendering all of the material descriptions to a G buffer. And then the lighting happens after the fact in a separate pass. And it would potentially be possible to open that up in Shader Graph so that you could edit the lighting there. But you would be editing the lighting model that's applied to the entire scene. And what we're doing is editing lighting that's applied to individual objects because of the architecture of forward and forward plus. So this is designed to work in URP in forward plus. It's not designed for deferred. You can definitely edit the lighting model in deferred, but that does require you to jump in and edit some shader code.
Awesome.
So yeah, everything that I've talked about so far is specific to Forward and Forward Plus? Great question.
Gotcha. We got one more and then we can dive back in, I believe. But Lindelius says, I probably missed this, but can you, for example, open up the light tuned subgraph, copy all of it over, and then tweak its subcomponents in your own shader graph? Once you kind of bring it over from the sample, you're able to customize it, right, Ben?
Yes, absolutely. And that is what I'm definitely hoping that people will do. So
Yeah.
from the samples, you can use the lighting models that we're providing directly if you want to. But what I'm hoping that you'll do is take these, figure out how they work, and then build your own so that
Mhm.
they're specific to your project. They do all the things that you want them to do and leave out the things that you don't need so that you can get better performance at the same time.
Yeah. I think it'll be exciting to kind of see people using the foundation that you've created, but then iterating off of it and building and adding their own ideas into it. I think that'll be very, very exciting.
Yeah.
Is there more that we wanted to talk about in the kind of custom lighting shaders, or are we ready to start taking a look at some terrain things?
Let me just kind of wrap this up
Sure.
in terms of custom lighting. We provide lighting models. We provide lighting model component subgraphs like diffuse and specular. And then you can also just build everything from scratch if you want to. So there's multiple layers here. You can just plop our provided lighting models in, or you can build your own with our, specular, diffuse, uh, ambient, or you can build everything from scratch if you want to. We're hoping that we can provide, as many tools as possible, so that you can work on this at the level where you are. And I'm really hoping that this will open things up so that people without any coding experience can really get in and make some like stylized, some really interesting looking projects and not just
Yeah.
go with like the default built-in lighting.
That's awesome. That's awesome.
Okay. Yeah, you wanted to go on and talk about our other topic, right?
And I'll go wherever you want to go. If you want to spend the
Uh,
rest of the stream talking about this, listen, I have nothing but trust for you. But if you're ready, let me know because I have a question that I think segues us nicely.
yeah, let's go with that.
Buzz DX, before we even started the stream, said, I hope shaders for terrain refers to the ability to put actual custom materials onto the terrain or general shader graph integration with template graph to customize it ourselves. Ben, what are we talking about here?
Well, the person that asked that question, that is exactly what we're talking about. So,
Buzz, this is for you.
um, yeah, so it's been a request that people have been giving us for a long time, to be able to create shaders for terrain with shader graph. And it has been possible before to a certain extent, but it required some kind of ugly hacks and it wasn't officially supported. But now in Unity 6.3, the world building team has been working hard and they've made it so that you can create shader graph shaders for terrain, and it's officially supported. It's a real feature, and it's really cool. I've got to play with it for quite a bit, and it introduces a ton of power into what you can do with terrain.
Awesome. I love being able
So
to make people's dreams come true. So even though it's one person who's like, I hope that's what it is, I love to be able to be like, you bet, we got it.
yeah, no, that's exactly what it is. So, Unity introduced terrain, I think, back in like 2007, something like that. The terrain system has been in for a really long time, and it works pretty well. You can create different layers with the terrain, which is what I've got here. And you can edit the materials for each of those layers, which is what I've got here. So you can see I've got a diffuse and normal map and a mask map here for my layers. There's a lot of different layer properties that you can adjust to change the way that the terrain looks and works. But there are some things that are missing. There's no way to edit the features of a layer. So for example, if you want your layer to be applied with parallax occlusion mapping, there's not an easy way to do that. If you want your layer material to be projected with triplanar projection, there's so that it looks nice like on the sides of cliffs and you don't get stretching. There's not a built-in way to modify the layers to be able to do that.
Mm.
And there are also some things that could be done to improve performance here, for example. So right now, this layer is defined using 3 different textures. And if you wanted to rearrange the way that that texture data is packed so that it was only sampling 2 textures instead, there's no way to do that in a layer. Um, so the system as it is now is pretty powerful, but there are some things that are missing and things that you can't do. And so what we've done, opening this up with Shader Graph, is allow you to do all kinds of new things. Shader Graph allows you to use like parallax occlusion mapping, triplanar projection, basically anything that you can create in a shader graph is now available for use on terrain, and it's really neat. Here in my notes, it says it really blows the doors off of what artists are able to do with the terrain system.
Ben, I feel like you might as well be on the marketing team at this point. You got it.
Okay. All right. So let me give you a quick tour of what this looks like practically. And then I will show you the sample content that we've created. So just in terms of making a terrain shader, let's see, which one of these did I want to show? Ah, this one. Okay, so what we've done here is, first of all, I'm going to open up the graph inspector. And so we've added, and this works in HDRP and URP, by the way, both render pipelines. We've added a new target here called terrain lit. So when you create a terrain shader, you want to use the terrain lit target. And there's a brand new node that we've created. So if I open my create node menu, I can come down here to the terrain category, and there's this node called terrain texture. And that's what this is. And this node allows you to bring in all of the material properties from the terrain. So if we look here, I've got 4 terrain layers set up, and they have properties like what textures they're using and the scale or the strength of the normal map and the color tint and those kinds of things. Those are all available from this node. So I can use this to bring in a texture, and this drop-down box down here at the bottom allows me to choose which texture I'm bringing in. So if I want to bring in my normal map, I can do it just like that. And then if I want to sample that, I just add my sample texture 2D node. And now I'm sampling my normal map. So I can also bring in the strength of my normal map, for example. So here's my normal map coming out, and I can just multiply that by the normal scale. Oh, actually, I think I probably want to use the normal strength node for that. But anyway, so all of the data that's here that's available for the terrain, I can bring into my graph using this node. And you might be wondering what this index input over here is. Well, that is the current layer that I'm on. So right now I'm on layer 0, now layer 1, layer 2, layer 3, etc. So this node is basically allowing me to bring in all of my terrain data, and then I can use that terrain data to build a graph. So I can build up everything that I need for an individual layer. And if I want to take a look at what that looks like, here is a graph that we created that imitates the layers as they're working now. So you can see I've got a couple of different instances of this terrain texture node. This one is bringing in my mask map. This one is bringing in my normal map. And this one is bringing in my diffuse map. And then I can combine those and output the material properties of the layer. So this subgraph represents one layer or one material that I'm applying to my terrain. And then I can combine these layer subgraphs into a full terrain shader that looks like this. So over here on the left, I have my standard layer subgraphs. And then here I have all the nodes that are blending them together. So that's kind of like a basic overview of how we intend for people to create terrain shaders.
Mhm.
You create individual layer subgraphs, and then you blend them together, and then that output is what you then apply to the terrain.
Awesome.
And then on the terrain itself, you can just come over here to the terrain settings and apply the material right there. And that will take your shader graph and apply it to the terrain, and you're good to go.
That's awesome.
So that's how the terrain system works in a nutshell. But what I want to show you next is the sample content that we're providing to help you get up and running creating terrain shaders. So again, we'll come up here under Windows, a window, package manager, and
This
scroll
guy's
down.
secret.
Yes, it is. Nobody will ever know.
Secrets. Except you all watching here. Congratulations.
And so we'll scroll down here to the bottom under terrain shaders. And this is brand new. I don't even know if the paint is dry on this feature yet. It's possible that you might even need to wait until next week to have the beta that has this in it. And I apologize for that. But here is our terrain shader sample content. And we've imported it. And this sample content has just an absolute ton of material in it. So here we are looking at it down here. It's available under samples, shader graph, terrain shaders, after we imported it from the package manager, obviously. So this has a whole set of sample terrain shaders. We have a huge set of terrain components for packing and unpacking materials, for doing hex tile blending. Here's all of our subgraphs for different types of layers, and then we also have some textures that come with the sample. But it's just like a massive amount of content that's available for people to use. And to help show off this content, we have our sample scene, which is what we've been looking at here. So if we pick actually, let me pick. So I've opened up our terrain URP scene here, and then I'm going to select this terrain samples showcase. And what that allows me to do is to navigate our sample scene using the graph or the inspector over here. So this scene is basically just like a whole bunch of little terrain samples, and every one of these, oh, well, thank you.
Yeah.
Every one of these pieces of terrain here has a different terrain shader on it so that it's really easy to compare their different features. So let's take a look. And if I scroll down here in the inspector with the terrain sample showcase selected, I have some navigation tools down at the bottom that allow you to pick which sample you want to look at. So right now we're looking at standard terrain lit, but I can pick like CHNOS dither, for example, and it just jumps me right to that sample, and we can take a look at these. Now, there are a couple of factors that differentiate these samples from each other. One of them is the texture packing scheme. So, and then by that, I'm referring to the way that the data is packed together in the textures. The standard way of doing it is you have a color map, a normal map, and a mask map. But you can also make it cheaper if you pack all that data into 2 textures instead of 3. And so the various samples here will do it one way or the other. And I'm calling these CNM, that's for color, normal, and masks, or
Gotcha.
CSNOH, and that's for color and smoothness in one texture, and normal occlusion and height in the other texture.
Whoa.
So the samples are either one or the other.
Gotcha.
The samples also use different types of layers. So some samples will have, well, actually, let me just show you.
Please.
I'll just, by the way, this drop down has the samples ordered from least expensive to most expensive.
Oh, that's
Okay.
convenient.
In terms of performance. And what I want to show is let's just jump automatically right to the most expensive one. This one is CSNOH hex parallax height. And that means it's using hexagon tiling to break up tiling artifacts. And it's using parallax occlusion mapping to make the surface look more interesting. And let me just kind of demonstrate to you what that looks like. So if I come down here, kind of close to the surface of the terrain, you can see that it's got these really nice looking bumps. So the shape of the terrain is, it looks like it's bumpy, but there aren't actually any additional polygons being used here. This is all being done with parallax occlusion mapping or ray marching, which is creating this effect. It just gives like a lot more shape to the terrain.
Right.
However, it's pretty expensive. And I want to show you this sign over here. One of the things that we're including from each of these examples is this relative cost. And what this means is it's like a multiplier for how much more expensive it is than the regular built-in terrain shader.
Ben, can you scoot down your vision? You and I are just blocking out the information. That's all. Sweet.
There we go. So you can see the relative cost of this one is 19.8. It's almost 20 times more expensive than the currently existing built-in shader. So I'm recommending that you guys not use this one in production. It's here so that you can compare it with the others, but this particular one is pretty expensive, and I don't recommend that you use it just because of the expense. There are ways of making this cheaper, and if we take a look, I'm just going to drop this down again. I'm going to pick the cheapest one. This one is CHNOS Array Dither, and this one is pretty interesting. Normally, each layer has 3 textures. And if I have 4 textures, that means I'm doing 12 texture samples. Plus, I'm sampling a mask map that determines where each of the layers goes. So for a standard 4-layer material that has 3 textures each, that's about 13 texture samples you're doing. But this one is using some really clever techniques for combining those samples together into a texture array. And instead of doing 13, it's only doing 6 texture samples. And what that allows it to do is it reduces the cost down to less than half of what the standard shader is rendering at. And yet you still get smoothness and normals and all of the features that a regular material has. So what we're shooting for here is we want to be able to allow mobile developers to put terrain on those devices as well. And so this is a method of creating a shader that's significantly cheaper than the one that's built in, so that it will run better on lower end devices.
This is great. I want to ask a question from Manu, who's
Great.
a Unity advocate and in the stream with us today as well. The sample that is 20 times more expensive, and we're like, hey, maybe don't use that. He's kind of asking, would that be more for rendering stills? What would the purpose of including that be?
So as I said a little while ago, there's a bunch of different factors that go into these shaders. There's the type of layer blending that's happening. There's the type of features that are in the specific layer. The reason that one's so expensive is that all 4 of the material layers that it's using are using both parallax occlusion mapping, which does dozens of texture samples, and hexagonal tile breakup. And those 2 features together combine to make it so that particular sample is using it might be somewhere north of 100 texture samples, which is really a lot. And the reason that it's there is to show you that you can combine these things in that particular configuration if you want to, but I definitely recommend against it. And what you could do instead is, if you have one particular layer that looks really beautiful with parallax occlusion mapping, you could use the parallax occlusion mapping layer just for that material, but you could make the other 3 layers cheaper. I hope that makes sense. So the reason that one is expensive is all 4 layers are doing like the most expensive in every option. It's kind of like if you go to buy a new computer and there's a bunch of drop downs for configuring the machine, and you just pick like all of the most expensive ones, you're going to end up with the most expensive, most powerful PC, right? And that's kind of what that example is doing. It's like you could do this, but you probably don't want to.
Gotcha.
Okay, we've alluded to it a little bit,
Mm.
but one of the things that you can do with terrain, or one of the problems that people have with terrain, is that it starts looking really tiled. And the built-in terrain shader um, basically just repeats the textures over and over.
Hmm.
And it's possible to break that up so that you don't see it. And let me just give you an example. So this is a simple blend texture. It's not doing anything specific to break up tiling artifacts, but because of the way that I've painted the different layers, you don't see the tiling artifacts as much. There's not like an emphasis on this, but I can still kind of see them. If I come over here, you can kind of see like there's this little green dot here that like repeats over and over.
Yeah.
And so typically, tiling artifacts are a fairly big problem to have on terrain. And so one of the things that you can do when you're creating a terrain shader in Shader Graph is employ various different methods of breaking up that tiling. So let's go ahead and switch over to some examples that just kind of show off what I'm talking about.
Yeah.
So here is an example. It's going to take a minute for there we go, for the terrain to compile. But here's an example where we're not doing any tile breakup. And you can see that this texture is just repeating over and
Yeah.
over. And it looks fairly unnatural.
Yeah, on
And
a
so,
flat plane, it makes it way more obvious. Like at least with the mountain, there was a little bit of kind of dynamic space that kind of broke it up a little bit. But as soon as
yeah,
it's flat, you're like, oh, okay, I
yeah.
can
And
see
I've
this.
designed these examples specifically to make it like as bad as it can be. So
Yeah.
it's obvious. So there are a bunch of different strategies for doing tile breakup, and I'm going to walk through a couple of them. But what I've got here on this sign here is each of these strategies comes with a performance cost. It's not free to do tile breakup. And so if you're on a lower end device and you need it to be cheap and you can't do tile breakup that's built into the shader itself, I have a couple of tips here on this sign as things that you can do for tile breakup that don't increase the cost of the shader. So the goal of the sample is to allow you to get your tiles broken up in whatever way works best for you. And if you can't afford performance wise to put tile breakup in the shader, those are some things that you can do to get tiles broken up anyway. So let's take a look at a couple of examples. This first example of tile breakup is the rotation method. And the way
Mm.
that this works is I'm sampling all of the textures in the shader twice. The first one is just normal, and then the second sample is rotated 90 degrees. And then those two different samples are blended with kind of a noisy looking mask map. And you can see here, there's still a little bit of tiling. You can sort of make it out, but it's better than the previous example. If we kind of switch back here, this one has got these like very definite corn rows going down it, right? But then this one, I'm blending between a material that's normal and a material that's rotated 90 degrees with a mask, and it breaks it up. So this one is a little bit more expensive, but not super expensive. I think most PCs and consoles could definitely afford to do this kind of tile breakup. Here's another technique where it's a similar kind of a method where I'm still blending between two different masks or two different materials, but the mask that is blending between them is generated procedurally based on where the most egregious tiling is happening. And so it's another way of figuring out, how do I break up these tiles um, and get rid of these tiling artifacts. And then the last method that we have here is called hexagon grid. And the way that this works is it splits up the terrain into individual hexagons. Kind of, I don't know if you ever played a board game where the board is made up of hexagons. That's
Like
kind of what this is
Settlers,
doing.
Settlers of Catan.
Yeah, like Settlers of
Yeah.
Catan, exactly. So, so what we're doing here is each of those individual hexagons has a random rotation, scale, and offset applied to it. And then the hexagons are blended across the borders of them, so that there's like absolutely no tiling whatsoever. And this terrain could go on forever, like out to infinity, and you'd never see any tiling at all. This method is really, really effective, but it also comes with a cost. So I wouldn't recommend doing this on a mobile device for sure. And probably not on a low-end PC as well. So you might want to use one of the cheaper methods if that's your hardware. But if you're making a game for like medium to high-end PCs and consoles, this technique works great, and it completely gets rid of tiling artifacts. Okay. I think that that's what we have to show.
That's awesome.
So the idea behind this is to really open this up and allow artists, with no coding experience, to create pretty cool looking terrain shaders that do all kinds of things. I didn't even show you the procedural shaders, but you can also create shaders where instead of painting a mask where the different materials go, you use the slope angle of the terrain and the height. Like if you want to automatically apply snow where the terrain is high, you could do all of these kinds of things, and the sample comes with examples that shows you how to do that. We want to really make the terrain system like flexible and open and available to use for artists who want to customize this and go beyond what the terrain lit shader has previously provided.
This is great. This is great. Ben, are we at a point where we want to start pulling some Q&A then?
Yeah, absolutely. Let's do it.
Unity community, I have been collecting questions throughout the stream. If you have any that you would like to ask now, we've got some time dedicated to it. So please just identify it with a big Q in the chat and we'll see what we can get. If we don't have answers, because Ben is one human, and while Ben's knowledge is extensive, it's not all-encompassing. We'll let you know that we don't have those answers, and we always encourage you all to check out our discussions page, as we have a number of Unity representatives in there trying to answer questions and provide insight when they are able. So we have a question from Boris Novikov. As we are just discussing Terrain Shader, they're asking, does Terrain Shader support light mapping?
Yes. Although, so it's really interesting. I talked about two main things on the stream today. I talked about customizable lighting and I talked about terrain. And it's not yet possible to do customizable lighting on terrain. So that may be something that we decide to add in the future. Terrains have always supported light maps. So you can bake a light map for your terrain, and that's kind of how the lighting works in terrain. But if the question was specifically about like, can I change the way that light mapping works in Shader Graph? No. The customizable lighting that I showed in the first half of the stream doesn't yet work on terrain.
Gotcha. Ben, while I ask this next question, take a peek at our private chat, because I have one that I want to get your opinion on, whether or not we talk about it on the stream. But
we can talk about that. Yeah,
we can talk about this one. Okay, good.
Yeah,
because I was almost I don't know. It was almost a secret, but Abdullah asking, is shader graph support for UI toolkit coming in 6.3?
The answer is yes.
That was like again, Ben's talking about how big of an update this is for shader graph with 6.3, that we already had one dedicated stream. We have 2 new features in today's stream, and there should be more questions more features in the future. And that is another big one that we'll hopefully have some more information on soon.
Yeah.
Krugisa says, so will URP shader graph have tessellation in 6.3?
No, we don't have that feature ready. So no, but I know that the world building team has a bunch of things on their list that they want to continue to add. And I believe that that's one of the things that they're interested in. We'll have to see, how the features get prioritized, but that's definitely one of the ones that they want to add in the future.
Awesome. What else do we have here? We have Marco asking, what is the difference between the possible gain to use simplified lighting model versus using a default URP lit shader with specular off or environmental reflection off activated?
So, yeah, I understand that the URP lit shader has the ability to turn off specular and reflections, and that's great. You can definitely get a little bit of a performance boost by turning those things off. But what I showed today is like orders of magnitude more flexible because, not only can you leave out a couple of features, but you can change those features. So for example, if you still want specular, but you just want it to be a little bit cheaper, you can do that. Like we provide several different models of specular, so you can kind of dial in the exact amount of savings that you want versus the feature set that you're looking for. So you can customize the lighting model to get rid of reflections, to get rid of specular, just like you can by unchecking those boxes. But you can go way beyond that, and do different versions of them, or stylize your rendering, lots of different things like that.
Awesome. We do have a handful more. People are curious today, and that's great. I mean, it's always exciting to be a part of the hype for something new coming our way. Lady Apollo asks, is there a way to know or even debug shader complexity in terms of optimization? This would be a great thing to have. And I think we kind of talk about it a number of times, Ben, where I'm like, do you just know, or is there like a rule of thumb? Is there a guideline that you're following? Is there anything kind of automated for people?
Yeah, so this is something that's really hard.
Yeah.
And there are two main components that you need for judging the performance of a shader. You need you need to know what the overall cost of the shader is, and you also need to know which individual components are expensive and which of them are cheap. In shader graph, we provide the heat map color mode, which is something that I may have shown before. Let me pull up a graph really quick and see if we can show this.
Sure.
Let's see. So can we show my screen again? Yeah, there we go. All right, so up here in the upper right corner, we have the category, or we have the color mode. And if I drop this down, right now the colors of the nodes represent which category they belong to. So the input nodes are red and the math nodes are blue. But I can also pick heat map. And what this tells you is which of the individual nodes are expensive and which of them are cheap. So you can see some of these nodes are black, which means that they have no cost. They don't contribute to the cost of the shader at all. Some of them are dark blue, these math nodes, which means they're really cheap. Then some of them are bright, which means they're a little bit more expensive. So you can use this mode to kind of, it's a relative performance cost that will show you kind of where your hotspots are. And in this case, the hotspots are the texture samplers and the branch too. So I mentioned that you need two things. You need to know like how much, what's the relative cost of each of the different components, and then what's the overall cost. Unfortunately, we don't have a good way of showing what the overall cost is. And one of the reasons is this shader graph itself, depending on what we do in the graph, it might be compiled into thousands of different permutations. And we haven't decided on a good way of choosing which of those permutations we want to give you the cost of. So that's one reason. But you really need both of those things. And usually what I do when I'm measuring the cost of a shader is I apply the shader to a mesh. I point the camera at the mesh so that I just have a scene with the camera and the mesh in it. And then I make a build of that very simple project and run it outside the editor. And I put a little frame rate counter on the screen and I like literally look to see what the frame rate is that I'm getting with that shader. And then I go back into Unity and I change the shader a little bit and run it again and look at the frame rate. That's the best way that I've found of judging the performance. It's not amazing. It requires you to jump through a couple of setup hoops. But in terms of accuracy, if you want to know, I just changed my shader, did what I do, make a difference. That's the best way that I know of doing that.
That kind of direct A/B testing, right? Turn it
Mhm.
on, test it, turn it off, test it. I like that.
Yeah.
Speaking of, we have a question here from Jihad saying, can we hot swap between a number of shader graph shaders for terrain at runtime, or should we put everything in one shader and toggle between different paths with Boolean parameters?
The answer to that question, I would say, really depends on why you want to do it. It is absolutely possible to hot swap between materials, and I've done that in a project where I wanted to, like you were saying, Jackson, A/B test things. I set up a little script that would automatically switch from one material to the next so that I could see, I've got like 4 or 5 different variations of this thing, and I want to switch to the different versions and, write down which one is the cheapest. So you can absolutely do that. I don't necessarily recommend building a huge, very complex graph, I think, which was the second proposal that that person was suggesting. I like to keep my graphs more simple, just because they're easier to maintain.
Awesome. We got a couple more for you. And again, Unity community, thank you for asking such thought-provoking questions. If you catch the stream after the fact, you can always drop a comment in the YouTube videos. Ben, I have seen you go back and answer questions. Now, not to suggest that Ben is always there and will answer every question, but there is a chance. You're saying there's a chance.
Yes.
Discapole says, I want to target my grass layer specifically, even if I don't know which index it gets from terrain. How can I? Can I forge to index 0 always?
Oh, that's interesting. Yes, if you wanted to tell it that, yes, my grass is always index 0, I think that would work fine. There are a couple of different strategies for going about this. The way that the terrain currently works, when you use the built-in shader that's not using shader graph, all of the layers are exactly the same. They behave the same. They have the same parameters and inputs. But if you build a shader using shader graph, you can make each of your terrain subgraphs different. So you could make one that works really well with grass. You could make one that works really well with cliff faces, for example. So you can give these layers different types of characteristics depending on the material that you're planning on adding to them.
We have a question from the legend themselves. The Bull, I want to say super fan. They're here all the time. #1 community member in my eyes, says, I know it sounds weird, but do you have any cool tricks to use lights as something other than light? And this came from the kind of conversation around the stylized lighting. And, I think we were theorizing on kind of like the black and white with the lights casting color. Any other kind of cool tricks or thoughts or things you've seen, Ben?
Yeah, I have. I'm trying to think. I've heard of some really interesting things done with that kind of a technique, but nothing is coming immediately to mind. I know that you can definitely do that, and especially with this technique here. Another example is you could set up your shader so that nothing in your scene had textures applied, but then your light source could introduce textures instead of introducing color, like the example that I showed. You
Interesting.
could set up your lighting so that the light sources made everything turn black instead of being lit. Um,
Mm,
the possibilities are really big. When you have the control over your lighting model, like this is giving you, you can do all kinds of really interesting things. Yeah.
yeah. I am excited to see it. Like I said, you kind of providing the foundation for people with the samples and then having people kind of come in and iterate and build off of it. I'm really excited to see.
I actually just
Uh,
thought of something else, Jackson. You could
Please.
use a light source to make things get clipped away. So
Oh,
if you wanted to, you build your world and then your light source is like cutting everything out. You could do that as well.
yeah. Which is interesting. Mr. Awesome also asked, have you ever used a shader to make negative light source, like something that shines darkness, which I think is pretty aligned, which is very, very cool.
Hmm.
Lady Apollo adding Enigma of Fear uses light to reveal objects or hidden decals, which I think is also very
Yeah.
interesting to see.
Hmm.
There was one clarifying question I wanted to bring in from Krugisa again. I didn't quite understand this part. Is a terrain shader per layer or across the entire terrain?
Yeah, that's a good question. So the shader is for the whole terrain, but then inside the shader, you specify the behavior of each individual layer using layer subgraphs. And like I said, you can the way that the terrain shader, the built-in terrain shader works is that all the layers behave the same. But when you're building it in shader graph, you can make each individual layer use a different subgraph so that you could have one that, works really well for grass, one that works really well for cliffs, that sort of thing. So it's significantly more customizable.
Awesome. Ben, I think we've kind of cleared the Q&A queue here. Again, if anyone has any questions that we weren't able to get to, we highly recommend that you check out discussions. There are many, many resources there, a lot of fellow Unity community members. And of course, you can also check out the Discord for similar resources and opportunities to ask some questions. Or if you drop a comment on this YouTube video, there's a chance, a likelihood, a potential that Ben hops in to give you an answer as well. If you want even more resources and you want short form, to the point knowledge about shaders, about optimization, about a number of different topics, please go and check out Ben's YouTube channel at Ben Cloward for some incredible, knowledgeable, well performed, well thought out tutorial content there. So everyone, please go and check that out. We've done it. We've come to the end of the stream, everybody. I want to say a massive thank you to you, Ben, the Shader Graph Wizard. A pleasure to work with always. Thank you for, again, coming in and dropping all of your knowledge, your wisdom, and experience here within the community. Thank you, thank you, thank you, Ben.
Yeah, our team has been working on these features for a long time,
Mm-hmm.
and we're super excited to see what you guys do with them.
Yeah, it's got to be such a rewarding feeling to see like the things that you've created that people use to create their own things. I think that's so
Yeah,
awesome.
right.
I want to continue the round of thank yous by thanking Jack, working behind the scenes to make today's episode possible. And I want to let you all know about our next live stream coming to the channel. This will be on Tuesday next week. We are going to be talking to a couple of people about how to get your game featured in a showcase. This will be a continuation of our speaker series. We're going to be speaking to Christopher Wolf from the Triple I Initiative and Jenny Wyndham from Wholesome Games on how you can get your games featured in showcases that we see each and every year. That will be on Tuesday, September 16th at 12 p.m. Eastern. That's 9 a.m. Pacific and 5 p.m. GMT. The biggest thank you of all from today's stream is to all of you in the Unity community for being here. If this was your first stream, we hope to see you again at a future stream. If you are here frequently, thank you for coming back and supporting each other. It is an honor to be a community manager of such a wonderful group of people. And that brings us to the end of today's show, everybody. My name is Jackson. Until I see you all again, have a great rest of your day.